All right, my friends, today, welcome back. We are going to be reviewing the properties of exponents we've been learning about all this week, okay? So I have lots of sample problems that we're going to go over together. What I do want to go over is on the side here, we're going to write all of the quick power properties that we are going to need for today. So the first one we're going to talk about is the product of a power. So remember that one is written like this. I'm going to use the letter A here. And if we're doing a to the power of m times the same base, we'll use a to the n. It's like we're saying a to the power of m plus n to get our final answer. A power of a power, that's when we have those parentheses. So it's something like this, where it's like a to the power of m, all raised to the power of n. That's like saying a to the m times n. M times n. All right, so let's talk about the power of a product. That means if I have two numbers in the parentheses like this, where it's like a, b, all raised to the power of m. That's like saying a raised to the power of m and b raised to the power of m. That's kind of like the distributive property. A quotient of powers. So it's just like the power of a product. It's the power of a quotient. So if I have something like this, where it's like a over b, and all of that is raised to the power of m, that's like distributing it and doing a to the power of m all over b to the power of m. Power of a quotient. Power of a quotient. That's going to be if I have, oh, I think I wrote this backwards. This one should go down here. And then the quotient of a power is when we have like a to the m divided by a to the n. That's like subtracting a to the m minus n to get our final solution. The zero exponent states that anything, we'll go with the letter a, to the power of 0 equals 1. And remember, we have one rule, that a cannot equal 0, because 0 to the power of 0 is 0. 0 to any power is 0, because 0 times itself is still 0. A negative exponent, anytime you have a negative exponent, that's your indicator that the number needs to switch to the other side of the fraction bar. So if I've got a to the power of negative n, we're going to flip it so it's 1 over a to the power of n. If you had a negative exponent on the bottom like this, where it's a minus n on the bottom, that negative exponent on the bottom is telling you to flip it over to the top. So it'd be a to the power of n. So the negative exponent is just saying, move me to the other side of the fraction bar. And our last property we're going to talk about is the identity property, which states that anything to the power of 1 is itself. So we don't have to write that extra 1 there. All right, so now we've got all of our properties sitting over here off to the side. Just a quick little review of what those are. All of those are available for you on Schoology, so you're always able to check those out. So just as a reminder, let's go ahead and start working on these problems. So our first one has us multiplying two numbers together. Because they have the same base, I can write it as an addition problem. A to the second plus 5, which means my final answer would be n to the 7th power. I can do the same thing with these 2's. They are multiplied together, so I can do 3 plus 2, and that'll give me 2 to the 5th power. If we're leaving things in exponential form, which is what our directions say, we would stop here. However, we could go and multiply 2 5 different times to get the next answer. For problem number 3, we have the same base of negative 2. So we can think about it as negative 2 times 2 plus 6. So we would get negative 2, got to keep those parentheses, to the power of 8. We're going to continue with that same pattern, z to the 10th times z to the 3rd. We would do z to the 10 plus 3 equals z to the 13th. All right, so changing gears, let's do some division. R to the fourth over R to the third. That's like saying R to the 4 minus 3, which would be equal to R to the first. Anything to the power of 1, we can just write as R. Let me scoot that over so we can see it a little better. Just as R. We don't have to write any exponent at all. We can just leave it alone. M to the fifth over M to the third. We're going to do M to the 5 minus 3 to get M to the second power. 15 to the fourth over 15. So we're going to do 15 to the fourth minus 1. If you don't see 1, we can see that invisible 1 sitting right there. So 15 to the fourth minus 1 would be 15 to the third. For number 8, we've got x to the 7 minus 15, which gives us x to the negative 8th. Anytime we have an exponent to a negative power, we need to flip the fraction. Because x is not currently a fraction, that means we put a 1 on top, x on the bottom, and we bring back that exponent as a positive once we flipped it to the bottom. For number 9, we've got a product of exponents here, a product of powers. So we're going to do 2 to the fourth times 3, which would give me 2 to the power of 12. Whoops. Remember, if I'm going too fast on any of these, you are always allowed to pause, catch up, and then keep playing the video. We're going to do x to the 6th power times 5, which would give me x to the 30th. Much faster to multiply than to write out 6x's 5 different times. For number 11, remember that everything in the parentheses is getting squared. So that means it's going to be 3 squared times z to the second times 2. So my final answer, we can leave it as 3 squared, or we could write it as 9 if they asked us for standard form, times z to the 4th power. Lots of exponents there. Next one says negative 5. So remember, we've got to keep the negative 5 in there. And that's being squared. And x is being squared. If we were to multiply, this is saying negative 5 times negative 5, which would give me positive 25x squared. Or you could leave it at negative 5 in those parentheses, just in case it ever asks you for that standard form. Number 13 has something to the 0 power. Everything in the parentheses is to the 0 power. So that's like saying negative 7 to the 0 power and y to the 0 power. Negative 7 raised to the 0 power is 1. Y to the 0 power is 1, which means my final answer would be 1 because everything in the parentheses was raised to the power of 0. On number 14, the only thing being raised to the power of 0 is y. And the reason is because that 0 is not touching the negative 7. So we would keep the negative 7 and we have the y to the 0, which we would, and think about it like 2 separate elements. It's 2 parts. So we keep the negative 7. This y to the 0 turns into 1. So negative 7 times 1, our final answer would be negative 7. Make sure you know the difference between 13 and 14. Number 15, we're going to do 2 parts here. So it's a power of a quotient, which means we're going to have to distribute that 3 to the top and the bottom. So I'm going to get x to the second times the third all over t to the third. We're going to simplify to get x to the 6th over t to the third. Those do not have the same base, so I cannot simplify, and that would be my final solution. For number 16, we're going to first distribute the square. So I've got 5 squared, m squared, 3 squared, and then z to the third squared by multiplying by 2. We're leaving it in exponential form, so we're going to leave it as 5 squared, or we could write 25 if they asked for standard form. M to the second does not need to simplify. 3 to the second could simplify to 9 if I was looking for standard form, or we can leave it as 3 squared, and then it would become z to the 6th. I have no common terms. I can't simplify the 5 and the 3 because they have different bases. So I have no common terms to simplify, and I would leave it alone. Looking at number 17, I'm going to do the same thing we did with 16. 3 to the fourth power, c to the fourth power. 2 to the fourth power, y to the second times 4, because we are multiplying that power. So I could simplify to 3 to the fourth, c to the fourth, 2 to the fourth, and y to the eighth. W to the negative 6. Anytime you've got a negative exponent, we flip it to the bottom. Because y is not currently a fraction, we have to make it a fraction by using a placeholder of 1 with the w on the bottom, and we bring back that exponent, but as a positive since it's moved to the other side of the fraction bar. For number 19, we've got a negative exponent on the bottom. That means it needs to flip up to the top. So now it's 1 times 2 to the positive third. Because we've moved that negative exponent to the top of the fraction, it's no longer a negative, it becomes a positive. So my final solution, because anything times 1 is itself, would be 2 to the third power. Or again, you could simplify it just to 8 if they asked you for standard form. For number 20, now keep in mind on these, some of them, if they don't ask for standard form or exponential form, they're going to likely be multiple choice. So you may have to recognize either answer, either 2 to the third or 8. All right, so for number 20, we've got a negative exponent. I like to take care of the negative exponent first. So what I like to do is do 1 over 2m to the third power. Now that I've taken care of that negative, because I don't know about you guys, I hate seeing those extra negatives. Now that I've taken care of that negative, now I can go ahead and simplify. So now I've got 1 to the second raised to the third power, m raised to the third power. I can't simplify, so there's my final solution. Number 21, same problem. Whoops. Same thing. I'm going to go ahead and take care of the negative first. I'm going to switch it to 1 over 3a all raised to the positive third, because I moved that whole thing down to the bottom. Because it's in parentheses, I no longer need to worry about that negative exponent. Now I'm going to go ahead and simplify. So I'm going to distribute the 3. So I'm left with 1 over 3 to the third power, a to the third power. You could simplify the whole number if I were to ask you to go into standard form. All right, so number 22 has a lot of negatives. Like I said, I like to take care of those negatives first, and I like to cross them out as I go. So I'm going to draw my little fraction bar here. This a squared needs to switch sides because it's a negative. So I'm going to put an a squared down here at the bottom. B to the fourth is already in the right place because he's a positive exponent. So we're going to leave him alone. The 3 is already in the right place because he doesn't have a negative exponent. The a to the negative third is in the wrong place, so I need to move him to the top. Now that I've taken care of all of those negatives, now I can simplify. The b to the fourth and the 3 are not going to simplify, so I'm going to go ahead and write them in, b to the fourth and a 3. We can simplify the a's by doing a to the third minus 2 because we're dividing. I get a to the first. That's a positive answer. So I put it on the top of my fraction bar, and I don't need to write the 1 as an exponent because anything to the power of 1 is itself. Looking at number 23, let's first take care of our negatives. Let's get rid of all those negatives, all those yuckiness. So the x to the square, the 28 is in the right place. The 7 is in the right place. This x needs to move. It's in a wrong place because it's got a negative exponent. So I'm going to bring that x to the second to the bottom and the y to the third to the top. And I like to cross them out as I go to make sure I move all of those elements in the set. All right, so now I can divide. 28 divided by 7 gives me a 4. That's going on top of the fraction because it's a whole number. 28 divided by 7 was a positive 4. Y to the third, there's no other y's to simplify, so it's going to stay on the top. I did cancel the 28 and 7 out by getting 4, so now I would just leave the x squared on the bottom. For number 24, I can't simplify the m's and the n's, but I do have this negative exponent that needs to move up to the top because it's in the wrong place. Any negative exponent needs to switch sides. So the m is going to stay on top of the fraction, m to the third. The n to the second is going to move up to the top. I'm left with nothing on the bottom, so we can either put a placeholder of 1, or we can totally erase our fraction bar altogether and be left with m to the third, n to the second. Almost done. We've got 2 more, I think. Yep, 2 more. So for number 25, I like to get rid of those negative exponents, like I said, first. So start with your fraction bar. 3 and 15 are going to stay in the same places because they do not have any exponents. Y is going to stay put because it does not have a negative exponent. What needs to move is that x to the negative fourth. It's on the wrong side of the fraction bar, so we'll move it to the bottom and make it a positive 4. Now I can simplify. 3 over 15 is going to simplify to 1 over 5. The y and the x's can't simplify, so I'm going to write x to the fourth first because it comes first alphabetically, and then we put the y. For number 26, I'm going to multiply my constants or my coefficients first. A 2 times 5 gives me 10. X to the second minus 5, because that's a negative 5. Think about it as minus. So I'm going to write x to the second minus 5. Then I have a y to the first and a y to the third. Now I can do some quick math. X to the second minus 5 gives me x to the negative third. That means it's going to go on the bottom. Anytime it's a negative, it goes to the other side. Y to the first plus third would be y to the fourth. So when I write my solution as a fraction, I write the 10 on top because it's a whole number, the y to the fourth on top because it's a positive exponent, and the x to the third on the bottom because it's a negative exponent. For number 27, I'm going to deal with the negative. I'm going to deal with what's inside first. I'm going to simplify the inside as much as I can. So I've got this r to the negative fourth. So I'm going to do 2, put the r on the bottom, r to the fourth, and then the s to the second stays on the bottom. Don't forget to bring back those parentheses times negative 3. Now it says negative 3 as an exponent. Because everything has to be multiplied by a negative, that means I'm going to completely switch my numerator and my denominator. So I'm going to switch. Whatever's on the top needs to go to the bottom. Whatever's on the bottom needs to go to the top. So now I'm going to do 2s squared on the bottom, and I'm going to do r to the fourth on top. All I did was I took care of the negative. I still have to do the third, but I took care of the negative by switching those locations. Now I need to distribute the 3. So I get r to the fourth times 3 over 2 to the fourth, or excuse me, 2 to the third, and s to the second times 3. So when I simplify, I get r to the 12th over 2 to the third times s to the 6th. All right, I am going to have to scroll down here so I can see those last few. Anytime we've got these negative exponents, flip the fraction first. So let's flip the fraction first. Get rid of that negative as fast as we can. So this is 3 over 6. We're going to make it now 6n to the 6th over 3n. By doing that, we're getting rid of that negative sign on the exponent, so it's still got an exponent. We just don't have the negative sign in front of it. Now we can go ahead and simplify what's inside. 6 divided by 3 is 2. N to the 6 divided by n would be n to the 6 minus 1, which gives me 2n to the 5th. Don't forget, that's all being squared. Let's move that down a little bit. So we've got a little bit more room here. So all of that's being squared. So now I need to distribute the 2. So I get 2 squared times n to the 10th because I did 5 times 2. Number 29, let's get rid of that negative sign first by flipping the fraction. So 4n squared w to the fourth all over 2n to the sixth w to the third. Put those parentheses back, and we still need to square it, but we did take care of the negative. Now we can simplify what's inside. 4 divided by 2 is 2. N to the second minus 6. W to the fourth minus the 3 on the bottom. So I get 2n to the negative fourth, w to the first. So I'm going to simplify that and write 2 over, put the n on the bottom, times w. Don't forget, this whole time we still are waiting to square our answer because we haven't dealt with that 2 on the outside. Now we can square it and get 2 squared, w squared, all over h to the 8th, because it was, n to the 8th, because it was n to the 4th. Now it's times 2 to make it the 8th. Our last one, we're going to again deal with that negative first by flipping the fraction. H to the 4th, y squared, over 6h squared, y to the 4th, all still cubed. Let's simplify what's inside. There's no constant up top. There's no coefficient. So it's a 1. 1 over 6 stays in my fraction. If you need to see the 1, you can write it. If you don't have to. H to the 4th minus 2 and y to the 2nd minus 4. So we're going to simplify. I get 1 over 6 still. H to the 4 minus 2 would be h to the 2nd. It goes on top because it was a positive number. Y to the 2nd minus 4 would go on the bottom because it was a negative number. I simplify by removing that 1, and I can't forget to cube my final answer. So I get h to the 6, that was 2 times 3, 6 to the 3rd, and then y to the 6th, because that's 2 times 3. If you guys have any questions, don't forget I will have office hours posted. If you need anything, please feel free to shoot me an email. I will see you guys tomorrow. Have a wonderful day.